So students, now we will now find out what should be the acceleration time graph. Okay. So acceleration time graph, like I told you when I was explaining you this diagram, that this is the free fall motion and acceleration is negative g. So acceleration is negative g. And what we also see that, because if I draw the velocity time graph, for instance, so the velocity time graph must be a straight line because acceleration is constant. Acceleration is the slope of velocity time graph. If I am saying acceleration is constant, uniform, so it can be only acquired by the straight line graph. And students, I'm drawing here the straight line graph which I'm talking about. So exactly this one. Okay. So this is the instant of the time when it hit the ground. Okay. And once it hit the okay, so before it hit the ground, don't you think the acceleration is negative g? So that's why I'm going to draw this graph, horizontal graph below the x-axis, and this value is negative g. Okay. Now what happened at the moment when it hit the ground? At that moment it is no more free fall motion. Why it's not more free fall motion? I explain you this is just it is going to impact. So what will happen actually, at this moment the ground has applied a force on the ball in this direction, right? But remember that, dear students, this is a variable force. Okay, this force will first increase and then this force will decrease. Okay, so this is a variable force and this force will change the direction of velocity. After the bounce, now the ball is going up, which means that due to this variable force, first of all acceleration will be no more negative g. Okay, so we know that according to Newton's second law, F is equals to ma. So if the force is positive, which will produce the positive acceleration, and the positive acceleration can be only we can get if this is a velocity acceleration. So I told you that this is a variable force which is producing the variable acceleration. And dear students, why this force is in fact variable? If you look in, when it hits it, actually the ball deforms. You understand? The ball squeezes inside. The ball, microscopically if you see, the ball is deformed inside when it is impact with the ground. So when it deforms and then it regains its shape, during this time the force changes, right? And that's why the acceleration will also change. So this is an instant of time when the force is increasing, and then this is an instant of time, when the force is decreasing, right? And after that, now once again the ball is in air. Okay, and ball is going up, so now the ball have once again the same acceleration, that is negative g. So that's why we will continue the same line because the ball is once again in a free fall motion. So you can safely say that this is basically a duration of collision. So we have seen that logically its answer should be option B. I hope you understand both.